Hello everybody, today we're going to be talking about how thermometers work. I hope you enjoy. What is heat? Heat, as you may already know, is the speed of which the atoms are vibrating or moving in an object. The slower the movement, the colder an object gets. If the molecules completely stop, it becomes the coldest temperature possible. Absolute zero. The faster the movement, then the hotter the object gets. For example, in a frozen object or a solid object, you would have these molecules that are vibrating. But in a liquid object or a gas object, you'd have molecules that are traveling really far distances. In gases, they travel away from each other and diffuse into the air. But in liquids, they just move around a lot more than solids. And because of this, liquids are usually much more warmer than their solid counterparts. Thermometers. Thermometers are a measurement and they measure heat. There are many ways a thermometer can work. Today we'll be talking about the electric thermometer and the classic liquid thermometer. Liquid mercury thermometers. The famous red liquid in thermometers work in a very simple fashion. When heated, the liquids expand to become larger, thereby taking up more space in the thermometer's tube. So the hotter it is, the more it expands and climbs up the tube. So as we already know, when the liquid is really high up, that means the temperature is really high. If it's really cold, the temperature will go down. And therefore, the liquid will go down because it doesn't need as much space. Digital thermometers. Digital thermometers are able to measure heat faster and more accurately than liquid mercury thermometers. But how do these thermometers work? It's actually because of the fact that heat reduces the ability to conduct electricity, aka it increases resistance to electricity. So for example, this is how digital thermometers work. They usually have a metal bar, coil, whatever it is, and it's getting conducted by electricity. When heat is around or touching the coil, it conducts the heat into the coil, thereby increasing the resistance of electricity inside the coil. Therefore, the electrons will stop. Well, not exactly stop, but they'll slow down. And therefore, a microchip can actually measure the amount of resistance a piece of metal can have. And that resistance is directly programmed to create the output, which is the Celsius or Fahrenheit of the temperature. And that's how digital thermometers work. Really interesting, right? Also, when it's colder, the conductiveness of electricity is actually much more higher. So when it's absolute zero, then the conductiveness is so high that electrons can move around freely in a metal bar, coil, or whatever it is. And that's called superconductivity. Goodbye, and I hope you learned a lot in this video. And I hope you like and subscribe.